Pilate so cynically asked, "What is truth?" And we find ourselves in a culture which denies the existence of truth. That used to be the quest of Western civilization, to seek truth. And we live in a culture which denies its existence, which is insanity. But how do we know what's really true? That's going to be challenged tonight, because we're going to talk about some things that we've all been taught, not only in high school, but in college, that isn't true. We're going to explore some of that. And what we're really going to try to touch on here are the boundaries of our reality. That sounds a little highfalutin, but it's actually a very real, practical issue that we all face. The more we know about what modern science really knows about our reality, the more comfortable Genesis chapter 1 reads. That may surprise you. But we're going to try to comfortably, without getting too technical, challenge the myths of our so-called science today. So before we go any further, I realize most of you that came tonight are old friends from many, many years. But just in case there are new people that you brought that don't know me, let me just start a little bit by establishing our foundational discoveries that changed our life. I'm a technical guy from way back, as you probably can infer. But there are two strategic discoveries that dominate my life since I was a teenager. The first discovery is that in your lap you have 66 books we call the Bible. Those 66 books are actually an integrated message system. What do I mean by that? 66 books penned by over 40 guys in a period of almost 2,000 years, and they didn't even know each other. What they have produced, we discover by examining it, is an integrated message. And I don't mean thematically that there's a theme in the old, fulfilling the new, and all that sort of stuff. No. What you need to discover for yourself is what I discovered early in my life, is that every number, every place name, every detail is there by deliberate design. And once you discover that, that's a staggering implication that this package of 66 books is designed in detail by a single author. And that's the first discovery. The second discovery is that the origin of that design had to come from outside our time domain, because it writes history in advance. And so epistemology, we'll use that term tonight, and that's a misunderstood term. Epistemology is the study of knowledge, its scope and limits. Don't waste your time taking that in college, because in college it's administered by typically the philosophy department, and it's simply a study of the different meanings of words through history. It doesn't talk about resources or tools. Epistemology is the study of knowledge. Now, our epistemological approach here is a very simple one, but an important one. If you carry nothing away from tonight but this following chart, it'll be worth your trip being here. The first thing you need to do personally is to establish the integrity of the design of that book that's in your lap. Discover its integrity, that it was designed as a package for outside time. You say you can't prove the Bible. Yes, I'm so tired of people saying that on television. They want to say something nice. Sean Kennedy, you can't prove the Bible, but, and then they try to say something nice. I'm tired of hearing, you can prove the Bible. How? By discovering the integrity of that design, step one. Step two, you'll discover that design from cover to cover on every page points to a person. The Jews call the Messiah. And you then, once you do that, you establish the identity of who Christ is. And you can do that from that book. Once you realize who he is, he authenticates the package for you. That closes the loop. That's your epistemological cycle. And it's bulletproof if you take those steps. And you can put yourself on a sound epistemological footing. Well, so much for the introduction. That's where I come from, and that's what dominates my orientation. But we're going to explore tonight a little bit about the myths of science. We're going to challenge specifically the myths of astronomy. Now, many of you know that one of my many hobbies, even as a kid, was astronomy. How many of you have had astronomy in your background as a hobby or whatever? Many, many. Okay, over half of you, sure. There was a time when I had money, a long time ago, I had a 14-inch celestron. I mean, I was serious about it. If you go up to Big Bear, you'll see that domed house that has the, it was like, we took astronomy seriously. And I have to tell you, I'm startled to discover that most of what I've been taught in college, let alone in high school, isn't true. And that's what we want to look at. You realize we've had myths of the past. You know, way back they talk about the flat earth, right? There was no excuse for that because Isaiah straightened that out long ago. But there's also, you may, if you study the history of science, there's a phlogiston's theory about what burning really meant, and that's a bunch of foolishness. You go through the history books. And what we now know today is chemical oxidation. Then we had Ptolemy. We had the Ptolemaic cosmology, who believed that, which was a geocentric universe. Everything revolved around the sun. That was the Ptolemaic. Ptolemy, by the way, is an interesting character. He was eclipsed, of course, by Copernicus with his sun-centered cosmology. Ptolemy is going to go down through history as having opposed the two great truths of science. The fact that we have a sun-centered solar system is one of the things he failed to perceive. And the other thing was he proved in his own mind couldn't possibly be a fourth dimension. And that's a matter of record. It's kind of interesting. And he proved that the fourth dimension was impossible because he just couldn't visualize a four-dimensional orthogonal situation. And so higher dimensional geometry now is the ultimate source of unity in our present conceptions of the universe. So Ptolemy is going to have a very unusual place in history. But then there's this whole business of ether that they were trying to measure and so forth, and as a medium for light. And the Michelson-Morley experiment punctured that whole idea, and that's dear to me too, because you know where Michelson-Morley did that experiment? At the Naval Academy, of all places. So that's dear to us that we're Annapolis graduates. The velocity of light. You've had speakers here that is part of the fellowship of the creative science thing, Barry Setterfield and so forth, that have pointed out way back, Romer and Olaf Romer, under the days of Descartes, he had such prestige in the scientific community, and everybody believed, as he did, that the speed of light was infinite. It was instantaneous. But it was Olaf Romer, an astronomer, by measuring the eclipses of the moons of Saturn, measured the speed of light and at 300,000 meters per second. But the whole scientific community failed to accept that for 50 years. They just ignored his results until an Englishman by the name of Bradley did the same thing, repeated that experiment, and demonstrated that the speed of light had a measurable finite speed. And so that was a big revelation back then. Barry Setterfield, a member of the fellowship here, and Trevor Norman here, and Trevor Norman published over 30 years ago that the speed of light's been slowing down. And I have dear friends that were among us here at Calvary that took me to dinner. Hugh Ross and his chairman, Alex Missler, all happened to be old friends of mine, took me to dinner to patiently try to counsel me not to fall into the trap that the speed of light, everybody knows it's a constant, and they tried to counsel me not to get carried away with this foolishness that it was, slowing down. And took me to dinner, and I was very polite, but I chose to ignore them. And we published all of that in our journals, as you know. And of course, that has been vindicated and in exciting ways. So the velocity of light thing, and I won't go through that whole story again, but basically, I got ahead of my slides here, so they'll be in the thing for what it's worth. The myths of the present time. Okay, those are past myths. In the present, we still live with the myth of evolution. When we say evolution, we don't mean evolution, we mean biogenesis. But the point is, that term is still taught in school. It's still the bedrock of our culture, even though it's provably false. And an increasing number of scientists have published clearly that it no longer is a viable explanation of our origins. And we're indebted to Michael Denton in 1986, and Philip Johnson, and Michael DeBehe, they've published books in recent years that have put the evolution thing, turned it upside down. And these aren't Christians, they're just clear thinkers. And interesting. So the evolution thing is to anyone that reads and understands, is foolishness, and yet it's still the bedrock of our culture. The velocity of light still being a constant is debated by many, and so forth. Let's take another thing, the nebular hypothesis. This is still taught in college today, okay? Because what is it? A typical quote from Immanuel Kant, I'll quote, "Some 4 billion years ago, the sun had ejected a tail or a filament of material that cooled and collected and thus formed the planets." Or some variation of that is what you will still find in astronomy textbooks, the solar origin of planets. Now, it turns out 21 years before Kant, this idea came from Emanuel Swedenborg, and he's quite a character, a mining engineer with quite a range of interests, and he also claimed to have psychic powers. And he came up with this nebular hypothesis idea from seances with men on Jupiter, Saturn, and places more distant. Does that give you some new confidence in Swedenborg? Don't laugh. There are people that take him very seriously. Some 20 years earlier, he had a chance to meet Edmund Halley, who is of Cambridge. He was famous for his predictions about the comet that bears his name. Well, he went to Immanuel Kant and Pierre Laplace, who was a famous mathematician. He lent his endorsement to Kant's theory that he got from Swedenborg, but he did it without checking the mathematics. He had the math background to puncture this. He didn't bother to do that. So the nebular hypothesis gained widespread respectability despite its mathematical flaws. Subsequent writers have continued to develop variations of the view even though increasing difficulties renders it very doubtful. What am I talking about? We know that the sun contains 99.86% of all the mass in the solar system. Think about that. The sun is virtually most of the mass of what we call the solar system, almost all of it. Yet the sun contains less than 2% of the angular momentum. The 9 planets contain 98% of the angular momentum. What's that got to do with anything? It simply means that the planets couldn't have come out of the sun and cooled. And this was known, by the way, at the time of Laplace a century ago. There's no plausible explanation that would support a solar origin of the planets. You can try to formulate one. It doesn't work that has any mathematical integrity. Now, it gets worse. James Jeans pointed out that the outer planets are far larger than the inner ones. That's very hard to explain. Jupiter is almost 6,000 times as massive as Mercury, almost 3,000 times as massive as Mars. And those are problems if you try to make a model that cause for that to have happened somehow. So this is the difficulty with current theories. There's other enigmas. As we study the planets, we discover they apparently are in pairs. The rapid spin rates among the planets are within 3% by pairs. And as you look at this, the Earth and Mars, Jupiter and Saturn, and Neptune and Uranus are within 3% of each other. Why? Why are they paired in their spin rates? Nobody knows. Earth and Mars have a virtually identical spin axis and the same tilts, 23.5 degrees. Why? Nobody knows. From the angular momentum, pairs of these planets that may have been brought, it appears that they were brought here from somewhere else. I'm speaking just in terms of secular conjecture so far, you follow me? Why does Mars have 93% of its craters in one hemisphere? The craters on Mars, 93% are in one half of the thing, and there's only 7% in the other half. In fact, as they study it, it would appear that 80% of those craters occurred within the same half hour. Why? Nobody knows. But these are unexplored aspects to their origins. This gets to some other conjectures that you've all heard about, the idea of dark matter. The quote that you see in many articles, dark matter makes up about 26% of the universe. Really? The first hint of its existence came in 1933 when the astronomical observations and calculations of gravitational effects revealed that there must be more stuff present in the universe than telescopes could see. That's a widely held belief of many of our top scientists today. Why? I'll show you why in a minute. There's also dark energy. Dark energy makes up approximately 70% of the universe and appears to be associated with the vacuum in space. Well, there isn't a vacuum in space, but that's a whole other thing we'll get into. It is homogeneously distributed throughout the universe, not only in space, but also in time. In other words, the effect is not diluted as the universe expands. Really? These things are non sequiturs, and yet they're widely held among scientists. In fact, you should stand back, and it's humbling to realize that all that we know about matter comes from a 4% sample. There are books that tell you 96% of the mass of the universe is missing. How many have heard that somewhere? That's ridiculous, of course, it turns out, okay? And most of you are familiar that they're chasing some of these things with big dollars. The Large Hadron Collider in CERN in Europe. It spans the border between Switzerland and France near Geneva. It's 300 feet underground. It's the largest machine in the world, a circumference of 17 miles. It's the fastest racetrack in the world, trillions of protons traveling at almost the speed of light, guided by 9,300 magnets. We spent a lot of money here. 600 million collisions each second, and we could go on and on about this thing. There's also a project we're going to talk about a little bit called the GEO 600. This is an attempt in Europe to measure, to try to find and measure gravity waves. And the pursuit is the relativistic gravitational fields implies the existence of particles called gravitons. These are particles that have never been seen that they're going to try to find, okay? Massless, uncharged particles moving at the speed of light, but so far undetected. Now, kind of interesting sidelight here, in making this project, they discovered that there's some noise they encountered, and in Europe, the head of Fermilab wrote them a letter suggesting that that noise might be due to the granularity, due to the fact that the universe is a hologram. And that's caused a whole stir. That discovery may be more important than the gravitons they were trying to find. And there are experiments going to be conducted this summer to try to confirm that. David Bohm, a confederate of Einstein, said he was a guy that happens to have, David Bohm's an interesting guy. His background was in plasma physics. He was fascinated with plasmas. We're going to talk about that tonight. But he came to the conjecture that the universe may be a super hologram. That's why this GEO discovery is so exciting, because it reopens that whole discussion. And so the GE 600 is a gravitational wave detector located in Germany and so forth. I won't go into, we have to go into all this stuff. Well, to give you some feeling what the money they're spending, it's designed to detect relative changes in distance, the order of 10 to the minus 21 centimeters, about the size of a single atom compared to the distance from the sun to the earth. That's accuracy. That's what they're struggling with. And so we'll see what happens anyway. I don't want to spend too much time on gravity waves other than they were predicted by Albert Einstein, but never been actually observed. And that's what the GE 600 is chasing. Okay, enough of all of this. Let's zero right in on the myths of the present. One of the statements that you see is there is a black hole in the center of that galaxy. Why do they say that? Well, if there wasn't, they can't explain its level of energy output. That's a conjecture to try to explain something they can't explain. There is invisible dark matter in that galaxy. Why do they say that? Because otherwise they cannot explain why it rotates the way it does. The way the galaxies rotate imply that there's not enough mass there to cause that to happen gravitationally, so there must be mass that we can't see. That's why they call it dark matter. Okay. Another statement you see in the current, I'm talking about current reports in your literature. 96% of the universe is made up of dark energy and dark matter that we cannot see. Really? That all we know about mass comes from a 4% sample? You got to be kidding. Otherwise, clusters of galaxies would fly apart because gravity alone can't hold them together. Really? Then maybe something other than gravity is operative here. Pulsars are made up of strange matter. That's another statement you see if you start reading in pulsars. Otherwise, they can't explain their oscillator-type behavior. But here's the fun one. Photographs of connections between two astronomical objects that have different red shifts are only chance alignments. Red shifts are supposed to be measuring the expansion of the universe. They have some things that are so close together, they're apparently associated, and yet they have different red shifts. That's embarrassing. How do they explain that? See, if they're only chance alignments, otherwise the Big Bang is being falsified, the whole Big Bang theory. Halton Arp was Edwin Hubble's assistant, a long-time observer at Mount Palomar and also Mount Wilson. His photographs contradict the whole concept of the Big Bang. And so he's not allowed to publish in most of the technical journals because they don't agree with his obvious conclusions. I'm reminded irresistibly of a passage in Lewis Carroll's story about Alice through the looking glass. You probably remember that from your childhood days. Alice, the White Queen in the story, says to Alice, or actually Alice says, "One can't believe impossible things." Alice laughed. The Queen says, "I dare say you haven't had much practice," said the Queen. "When I was your age, I always did it for half an hour a day. Why, sometimes I believed as many as 6 impossible things before breakfast." Now, this is Charles Dodson, otherwise known as Lewis Carroll, his way of poking fun at the irrationality there. But how interesting it is, that's exactly what's going on in our so-called scientific fields. They're forced to accept things they know can't be possible. So I want to talk a little bit before I go further on what I call Epistemology 101. Epistemology, study of the origin, scope, and limits of knowledge. We take pride in a methodology we call the scientific method. How many have heard of the scientific method? The other name for that, more properly, is called the empirical method. What is the scientific method? If I gave you a written quiz, I imagine a few of you could pass, because here's what that really means. Step 1, you observe a phenomenon. Step 2, you seek patterns and measures in that observation. Step 3, you formulate a hypothesis from that description. And then the fourth step is you gather independent data to challenge that hypothesis. It's that simple, and yet it'll shock you to discover that it's rarely practiced in certain fields of science because they can't repeat the experiments that they're trying to explore. See, the search in scientific method is a search for failures, not successes. Theories can never be proven. Did you know that? That comes as a shock unless you've studied this field of study. That theories can never be totally proven. What they can do is defy being disproven, but they're never fully proven. They just they develop a reputation for being difficult to disprove. There's a big difference there, a profound difference there. When you study information sciences, Shannon calls what he calls verifiability the definition of meaning. Something that can't be verified is defined in information sciences as meaningless. If you can't verify it, it's a meaningless statement. For example, if I suggested to you that before this talk is over, all clocks in the world are going to slow down by 10 seconds. Well, if all clocks in the world slow down by 10 seconds, there's no way to prove that. That's what we call a non-verifiable statement, which means it's meaningless. See, it only has meaning to the extent it can be verified. Untestable statements are defined as meaningless. We need to grasp that. It's important. The great tragedy, according to Huxley, the great tragedy of science is the slaying of a beautiful hypothesis by an ugly fact. Non-falsifiable hypotheses are non-scientific, and by the way, they're intellectually dishonest. And yet we'll discover our lives are full of those. In logic, there's a classic error in logic. It's called argumentum ad ignorantiam, and it's an argument from ignorance. The assertion that something must be true simply because it hasn't proved false is an error in logic. Just because it hasn't been proved false doesn't make it true. We need to understand that. It's fundamental in our thinking. Well, since the scientific method is really not available in certain fields of science, archaeology, geology. There's a number of places where you're studying something, you can't get a repeatable type of situation, so you go to alternatives. What are the inadequate substitutes for the scientific method? The first is the deductive method. That's where you derive theories by generalizations about the universe. They may be useful, but they're not necessarily true because they haven't been verified. Another alternative, and this is the one that we've all been injured by, mathematical proofs. Elegant consistencies that occur within a synthetic universe, a man-made, and mathematics is a synthetic universe. Mathematics is a collection of symbols and rules that create a synthetic universe. It doesn't necessarily bear relevance to reality. That may shock you. Elegant consistencies within a synthetic universe, models are not reality, no matter how elegant they are. You've got guys like Stephen Hawking and a number of these other mathematicians, they're absolutely brilliant. And they explore and dive into subtleties of these incredibly elegant, complex mathematical models. That doesn't make them correct. It doesn't mean they have anything to do with reality. That is yet to be demonstrated. And so there's another source of error. That's even equations that prove to be correct may be correct only within certain domains of validity. What you know about the weak and strong nuclear forces have nothing to do with gravity. They're true with what happens within the atom in very small distances. What happens in gravity is quite different. Well, we're going to see quite different what happens in the galaxies. I'm going to demonstrate that to you in a minute. Okay. Now here's probably the most disturbing one of all. When all these other things fail, if you're a scientist, your next challenge is to get your thesis, your paper published in a journal, in what we call a peer-reviewed journal. And the process that occurs, it sounds pretty good at first. You have people that are your peers make comments on your paper. But think that through. That whole process has a tendency to ossify the field of study. Because if your paper challenges the common understanding, you won't get published. You see, you're having to have your competitors control the gateway to truth. So why are we surprised that science, especially as science starts to involve larger and larger sums of money, it gets harder and harder to get that money because it's controlled by people who have a vested interest in the status quo. So it turns out that these methods all are very frail and do not necessarily lead you to truth. So I want you to realize that inference is not proof. Something may seem true, fine, that's an inference. Doesn't mean it's been proven. The other thing you want to guard against is avoiding the logical fallacy of asserting the consequent. What do I mean by that? If A, then B. If B is true, then A must be true. For example, if it is raining, the street is wet. Well, the street is wet, therefore it must be raining. Not necessarily. This ignores the possibility of an alternative. A street cleaning machine may have just gone through. I mentioned, see, asserting the consequent is a common failure of logic. If you're not watching for it, we all do it, and it's wrong. The illusion of knowledge, the only one certain barrier to truth, is the conviction that you already have it. You know, our trademark Bible verse for over 40 years has been Acts 17:11. Be like the Bereans, in that they received the word of God with all readiness of mind, but searched the scriptures daily to prove whether those things be so. The difficult part of that policy isn't searching the scriptures daily. The difficult part is having an open mind. Because we're all victims of our presuppositions. We need to guard against that and recognize that. Fortunately, the greatest obstacle to discovery is not ignorance, it's the illusion of knowledge, the belief you already have the truth. The Lord has been echoing in my mind, in my life, I go back, I can mention several places, been echoing in my mind, for reasons I couldn't explain, a phrase. I don't know where he gave it to me. I woke up one morning with this obsession. Metaphors reign, where mysteries reside. And that bothered me. What does that mean? And I've been chewing on that for over a year now. Metaphors reign. See, when we don't really understand something, we give it a fancy name to hide the fact that we really don't understand it. That's part of what's going on here. I want to contrast science with technology. Most of us use those terms as equivalencies. What's the difference between science and technology? There's a very important difference. By the way, something else I just mentioned as I grow in the word, I'm convinced there are no synonyms. I think two words can be synonymous in that they mean almost the same thing. But watch out for that word almost. When Matthew uses the term kingdom of heaven, and Mark, Luke, and John use kingdom of God, 99 out of 100 commentators say, well, those are synonymous. No, 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 no. Because the kingdom of heaven is a genitive of source, not a genitive of apposition. And Matthew's being more precise. And out of that comes a whole discovery. Because he uses that term 33 times. At 5 times he used kingdom of God, which proves that they're not synonymous. So the point is, watch out for the so-called synonyms. There are treasures there. Well, science and technology, we tend to use synonymously. No, no. Technology produces useful products. Technology produces useful products. That's why we have computers and pacemakers and thousands of appliances, information appliances, and other kinds of appliances in our lives, because they're useful. That's technology. Science has become a religion with its own priesthood. And we need to be on the guard of that, because it's a subject of presuppositions, myths, and so forth. Now, let's talk a little bit of the milestones of influence throughout, Johannes Kepler, in the 16th century, he discovered that planets are in elliptical orbits with sun at one of the foci, that the sun's radius vector sweeps equal areas in equal times, and that planets' squares of the periods are to each other as the cubes of their mean distances. Now that, in his day, was a profound advance in understanding that explained the motions of the planets in the solar system. And it was within a decade later that another guy was born by the name of Sir Isaac Newton. And he carried that principle of Kepler substantially. He established the basis of classical mechanics, advances in optics, differential and integral calculus, and he was a serious Christian, by the way. That's the other thing interesting about these early founders. You may not know that Sir Isaac Newton wrote over a million words on Daniel and Revelation. I have the copies. It's interesting reading. He wrote on hermeneutics. But he's most well known, and he changed the world with his what's known as the inverse law of universal gravitation. And I want to talk about this because this one contribution of his changed the whole scientific landscape. And the inverse square law of the theory of universal gravitation. And what most astronomers fail to do is recognize that inverse square law aspect of that. This was his equation, that the gravitational force is equal to a constant having to do with units. It's the product of the masses divided by the square of the distance between them. And we'll talk a little bit more about G. It's not that important for us here. But I want you to remember this d squared underneath. In other words, you take the product of the two masses that are being attracted, and you divide by the square of the distance between them. That gives you Newton's law of gravitation. The whole field of astronomy is obsessed with gravity, but they fail to really understand that d squared thing, and I'll show you what I mean by that. Well, after Newton, we run into a guy by the name of Ben Franklin, 1706 to 1790. And while he did many things in his life, for our purposes tonight, there's one event had. The amazing thing was he wasn't electrocuted. He was stupid enough to fly a kite during a lightning storm. And he risked electrocution, but he determined that the sky was inherently electrical in nature. And the entire scientific community chose to ignore that. It's amazing that it took, several centuries for that to be realized in the scientific community. It's still just being recognized by the astronomers. I'll show you what I mean as we go. After Ben Franklin, we have a guy by the name of Michael Faraday, 1791 to 1867. He's the one that pioneered the concept of electromagnetic fields. In fact, Albert Einstein kept a photograph of Faraday on his study wall alongside Isaac Newton and James Clerk Maxwell. Faraday was highly religious. Here's another Christian, member of the Christian sect that demanded total faith and commitment. And even the biographer said he had a strong sense of unity of God and nature pervaded in his life and work. Boy, I hope they say that about all of us in our epitaph, if you will. Now we come to a guy that we're going to talk a little bit about tonight, because he's ignored by most people who get into, unless you either ignore him or you really get into him. Very few people in the middle. A guy by the name of James Clerk Maxwell. He codified the basis of all that we know about electrical science and engineering into a self-consistent set of equations. Originally 20, finally boiled down to 4, but all about electric currents, magnetic fields, that they intrinsically are connected. That magnetic fields, electric currents, magnetic fields are intrinsically involve a common behavior. And that electromagnetic energy propagates through space. So far, so good. Thank with Sir Isaac Newton and Albert Einstein in the fundamental nature of his contributions in quantum theory, electromagnetics and electrostatics, thermodynamics, information theory, and cybernetic. Quite a guy, by the way. Okay? But along comes a guy by the name of William Thomson, who gets knighted, and he's known as Lord Kelvin. And from 1824 to the turn of the century, to 1907, he becomes an incredibly influential scientist in 1900 Great Britain. Lord Kelvin, profound influence. He was knighted for his work in thermodynamics. That's the good news. Let me give you the bad news. He was an outspoken critic and very pessimistic about the future of electricity and electromagnetic theory. He predicted that radio and wireless telegraphy had no future. Now, we laugh at that today, but he cast a pallor on that as far as the British scientific community is concerned. And as you study the history of science, you'll discover that from Kelvin on, the British Astronomical Society goes one way, and a whole nother field of study is ignored by them that comes out of Norway, Sweden, and the northern latitudes. And that's what we're going to focus on tonight. But Kelvin was a cloud on this whole picture. And so I want you just to recognize the negative influence of this one man. Now, before we go any further, you need to have something else that I want you to do. I want us tonight, we want to have a way to somehow relate to extreme magnitudes. Scientists use fancy numbers to represent large magnitudes, but often they don't really understand that. I remember I was with Edward Teller and his sidekick Norris Keeler, and they were talking about 10 to the 17th something or other, and I said, gee, that's more than there are seconds in the history of the universe. They looked at me startled. What do you mean? Well, you're the guys who are going to try to tell me that the universe is about 15 billion years old. That's only 10 to the 17th seconds. They were startled. Just do the math. See, they used those numbers, but they didn't really have an appreciation of the science. We need to have an apprehension. Let me give you a new word that's in our vocabulary today to demonstrate what I'm talking about. We have a new word called trillion. How much is a trillion? I have yet to find a congressman or senator that can answer that question. I'm serious. How much is a trillion? Okay. My old friend Bill Ruggles is here, and he and I got into some strange investments years ago. And if I said to Bill, I know I owe you some money, but I'm going to pay you back in 1,000,000 seconds. Bill would take out his calculator and a million seconds. Well, that's 12 days. I can live with that. Oh, I'm sorry, Bill. I misspoke. I'm going to pay you. I'm going to 1,000,000 seconds. That's 12 days. I misspoke. I meant to say I'm going to pay you in 1 billion seconds. He gets his calculator out. How long is 1 billion seconds? 32 years. You see, that's not only a quantitative difference. That's a qualitative difference. He knows that ain't going to work. I said, oh, Bill, I'm sorry. I misspoke. I'm going to pay you back in 1 trillion seconds. How much is that? 32,000 years. You see the point I'm trying to make? Million, billion, trillion. 12 days to 32 years to 32,000. Those are qualitatively different. We live in an economy with 14 trillion gross domestic product per year, carrying a debt of 800 trillion. Come on, what are you talking about? Check it out, it's important. Well, now let's get back to our subject at hand. How big is our galaxy? We can talk about all kinds of things and still not relate to how big the galaxy is, okay? There is a model suggested in the handbook of the Celestial Handbook by Burnham, that's worth our consideration. It turns out it takes advantage of a coincidence. It turns out that the number of inches in a mile turns out to be about 63,300, give or take. The number of inches in a mile. It also turns out that in astronomy, a standard unit of measure is called an astronomical unit. It's the distance between the Earth and the Sun, okay? It turns out the number of astronomical units, which happen to be about 93 million miles, the number of astronomical units in a light year is the same number, almost. They're almost the same number. The number of inches in a mile and the number of astronomical units in a light year. That's going to be useful to us just to build a model, okay? The distance from the Sun to the Earth is called an astronomical unit. It happens to be 93 million miles. That's just a basic unit in astronomy. In Burnham's model, we're going to let 1 inch represent the distance from the Sun to the Earth, and we're going to let 1 mile represent a light year. You with me so far? Okay. Robert Burnham's handbook, Celestial Handbook's 3-volume standard stuff. Okay. Well, the Sun is 880,000 miles in diameter. In other words, on our model, it's about 0.009 inches. So our Sun, in our model we're going to build, represent a dot of a very sharp pencil. Call it like a period at the end of a sentence. That's going to be our Sun. You with me? Okay. So it's 1/100th of an inch, a tiny little speck. All the planets will turn out to be within a 7-foot circle diameter. The Mercury would be 4/10 of an inch away from that dot. Venus would be 7/10 an inch from that dot. The Earth, by definition, would be 1 inch. 1 inch being an astronomical unit. You with me so far? Okay. Mars would be about 1.6 inches. Jupiter about 5 inches. Saturn about 9.5 inches. Uranus about 19.2. Neptune 30 inches. Pluto would be 39.5 inches. Roughly a meter. So our whole model, if I was building the model of the solar system here, with the Sun being a little tiny period, the whole thing would occur within a 7-foot circle, 1 meter in radius, call it, okay? You with me so far? Now, the nearest star is a entity about the same size of our Sun that's 4.5 light years away, okay? If our nearest star is 4.5 light years away, I make a speck the size of the period. Here's the Sun over here. I've got the rest of it laid out 39.5 inches out here, right? I've got to make a representation of that star, Alpha Centauri, 4.5 light years away, which means it's 4.5 miles away. I suddenly have to get a larger piece of paper, okay? So 4.5 miles away. My question to you is, how much gravity do you think is operative between a speck the size of a period and another speck the size of a period 4.5 light years away when I have to square the distance between them? The answer is gravity has no impact, has a negligible impact, right? If you imagine these two stars in the size of golf balls, one of them's here and the other one's in Denver. You get how much gravity is between two golf balls separated by almost 800 miles. You see what I'm getting at? So the Milky Way, in our model, would be 100,000 miles in diameter. See, you get a feeling of the vastness of these spaces. Now remember, in Newton's thing here, the square of the distances is that the distances are squared, and they divide into that. That minimizes the impact. So we're going to explore a little bit what I call the boundaries of reality. And I'm going to use Da Vinci's Vitruvian Man as just a symbol of man's reach. And we're going to take size getting bigger to the right. So things that are larger than man, we call the macrocosm, And that leads to the study of astronomy and astrophysics. And the great discovery of 20th century science was that the universe is finite. It might be big, it might be expanding, but it's finite, not infinite. That has staggering implications. That's what led to the Big Bang conjectures and other things. Huge, huge. We're going to explore the other direction for even more bigger shocker things, the smallness, which we call the microcosm. Let's talk for just a moment about the model of an atom. We generally represent that by a nucleus and electrons spinning around it, right? Now, we know this is obviously not to scale. We know that the nucleus is in the neighborhood about 10 to the minus 13 centimeters. Okay, that's very small, but it's measurable, all right? The electrons moving around that are in the neighborhood of 10 to the minus 8 centimeters. What we're interested in here is the ratio between them, okay? The linear ratio between them would be 10 to the minus 8 divided by 10 to the minus 13, or 10 to the fifth. What I mean is that the orbit of the electron, if I want to visualize it that way, is 100,000 times the size of the nucleus, right? 10 to the fifth. Are you with me so far? But that's linear. If I'm laying this out in terms of area, I've got to square that. If I'm going to talk about volume, I've got to cube it. So the volumetric ratio is that thing cubed, okay? 10 to the fifth cubed is 10 to the 15th. What does that mean? That means the amount of substance in the atom compared to the volume it takes is the same ratio as 1 second has to 30 million years. Let that sink in for a minute. I have a podium up here that feels pretty solid. Tim, our technician, would assure me that this is as solid as the technology can make it, right? And Bob Schober challenged that and says, no, there's nothing here at all. He's more correct than I am by a ratio of 1 second to 30 million years. This is mostly empty space. Why does it feel solid? Because the molecules that make up my hand are colliding with the molecules that make up this podium to create the illusion it's solid. And it's a very effective illusion, but it is an illusion. We are the victims of a digital simulation. Now, it turns out, if I take a line, let's say I had a piece of string up here and I cut it in half, if I cut it in half, I could take the half that's left over and do that again, couldn't I? So I can take the half and divide it in half. I can take that half. I could keep doing that, right? Conceptually, you think I could do that forever. It might get too small to do it practically, but you could, at least in your imagination, whatever I've got left, I cut in half, I throw the other way. It turns out there's a discovery to be made here, because if I keep trying to do that, I get down to a point, it happens to be 10 to the minus 33 centimeters, where if I cut that in half, that loses locality. It becomes everywhere at the same time. Why? Okay, it turns out that length is made up of indivisible units. They're called quanta. That's true of length, it's true of mass, it's true of energy, it's even true of time, okay? If they get smaller than the Planck limits, they lose what we call locality. So we discover that there's a limit to largeness at the macrocosm. That's understandable, perhaps. We can sort of grasp that. What we can't handle is we go smallness. There's a smallness below which we can't reduce. And we discover we are in a digital simulation. Okay? The Planck length is 10 to the minus 36 centimeters. Planck time is 10 to the minus 43 seconds. There's not a unit of time quicker than when the light changes and the guy honks behind you. No, the smallest unit of time is 10 to the minus 43 seconds. I'm convinced that the twinkling of an eye is 10 to the minus 43 seconds. Not the blink of an eye, the twinkling of an eye. So every physical dimension we encounter, length, mass, energy, time, is made up of indivisible units. That tells us we discover that we're inside a digital simulation. And so this is the big thing. So if you look at the metacosm, the whole big picture, we are in a finite digital simulation. Now, scientists are concerned about some of these so-called constants of physics, and they're busily trying to verify the constants appear to be changing. Because not just the speed of light, there's other constants they're even more concerned about. Scientific American, June of 2005. Their words: if these constants are changing, our universe is but a shadow of a larger reality. And when I saw that, it blew me away. I felt like saying, no kidding, Dick Tracy. That's what the Bible has been saying all along. The more you know about quantum physics, the more you know about the boundaries of our reality, the more you find that that is expressly mentioned in the Scripture. We now know that we live in 4 dimensions, not 3. That's what Paul says in Ephesians chapter 3, verse 18. He lists the 4 dimensions of our universe in Greek. Interesting. The more you know about the frontiers of real science, the more comfortable the Scriptures. You discover it's way ahead of us. And are we surprised? We shouldn't be. Okay. So we have molecules. We take some of these atoms and they'll start sharing electrons, making molecules and so forth. That's going to lead to something else I want to talk about. If we take gas and add energy to it, it becomes plasma. And if I use these symbols of the large symbol being oxygen and the other little symbols being hydrogen, if they are together but the energy is so high that they're not directly associated, that is a ionized gas called plasma. If it cools down a little bit so that the hydrogen atoms stay associated with the oxygen atom, that becomes H2O as we think of it, as a gas. We call it, it's as a gas. And if we cool it down a little further, it becomes a liquid. That's the way we generally encounter H2O as a liquid. And if you cool it down further, it becomes a solid. Sometimes that solid will be in the crystalline form, but it's still a solid, okay? The real point I want to make here, there are 4 states of matter. In school, we typically are aware of 3 of those. A solid, add energy, it becomes a liquid. Add energy, it becomes a gas. Add energy, and it becomes a plasma. Many writers in the press confuse plasma as simply an electrified gas. No, it's a different state of matter. It has behavior that's distinctive, and that's the shocker that comes out of all of this. And so the 4 states of matter. The entropy is maximized for the plasma. The entropy is minimized as a solid. Okay. Now, astronomers explain their views about it. See, they can relate to gravity. We can visualize gravity every time an apple falls to the floor. We understand gravity, we think. So they try to explain what they think they know about the universe in gravity terms. They rely on 17th and 18th century tools of their forefathers, Kepler and Newton, whenever they deal with gravity, fluid mechanics, magnetism, lodestone, rather than those tools of the 19th century. They never bothered to learn James Clerk Maxwell's discoveries. People who go into electrical engineering really learn that stuff and produce products as a result of that. But Clerk Maxwell's electromagnetic field theory. Furthermore, the astronomical conjectures are not empirically based. They're not done by scientific method. They're conjectures upon conjectures. They ignore data that does not support the presuppositions or the preconceptions. Therefore, they must postulate particles they've never seen and forces they have not experienced. If you read about the frontiers in astronomy, constantly talk about particles they haven't. They're spending a fortune on trying to find particles that they've never seen and forces that they haven't experienced. Why are they hunting for them? We have no reason to believe they exist. Not really. If you've been through some of our materials on quantum physics, you may remember this chart. I only want to get one number out of it. We have gravity and electromagnetic and their relative strengths. Electromagnetic strength is about 10 to the minus 2 of the strong force. The gravity is 10 to the minus 38. It's the ratio between those two I want you to be aware of. The electromagnetic force, there's 4 forces in the universe, but the electromagnetic force in the universe is 10 to the 36th times as strong as gravity. I want that to sink in. Not 36 times, 10 to the 10 with 36 zeros after it, times as strong. It can be that much different, okay? And by the way, it can go positive or negative. Gravity attracts but doesn't repel. Electromagnetic does both. Oodles more, okay? Now, the effects of gravity are minuscule. The effects of electromagnetism can be 10 to the 36 times as great. The entire volume of our galaxy is filled with diffuse clouds of magnetized plasma, electrically charged ionized particles. 99% of the matter in the entire universe is in the form of plasma. There's no missing mass. It's in a form that's been ignored by the astronomers because it may not be visible, because plasma is only visible under certain conditions. Now, on August 8th of 2010, there was a hidden aurora found near New Zealand. This was observed from the International Space Station. You're looking at this from above it, and that's obviously, if you'd make a guess, that looks electrical to me, right? And surprise it is. So what we're going to discover is there's a group of pioneers, scientific pioneers, that are all from Sweden or Norway, the high latitudes. Why? Because they're confronted with the auroras. And they got curious, what is an aurora? They started studying. Christian Birkeland is one of those, 1867 to 1917. He made a heroic commitment gathering data. Instead of theorizing, he went out in the cold, long nights. Their nights go for months, right? And gathering data, risking his life. In gathering that data, he learned a lot about auroras. He was the first to recognize the electric currents flow from the sun to excite plasmas in the Earth's upper atmosphere. He discovered the twisted, corkscrew-shaped, high-intensity currents in the plasmas that follow magnetic fields rather than across them, the so-called Birkeland currents. And he was nominated for the Nobel Prize in physics 7 times. His portrait remains on the kroner, the 200 kroner Norwegian currency to this day. Interesting guy. He was succeeded by Irving Langmuir, 1881 to 1957, roughly the same birth and death of my dad. It happens, coincidentally, that's why I happen to remember it. He discovered the double sheath, or the double layer effect in plasma. I'll show you that in a minute. He coined the term, he's the one that coined the term plasma to describe the almost lifelike, self-organizing behavior of these ionized clouds in the presence of electric currents, magnetic fields, and foreign bodies that are inserted in them. These plasmas start to behave in an organized way because of the laws that they follow, which are very different than non-plasma materials. He invented the Langmuir probe, which is used to this day for research here. Now, there's double layer phenomenon. One of the most important properties of a plasma is its tendency to isolate one section from another electrically by a wall of 2 closely spaced layers. They call that double layer. One of positive charges, the other negative. It does this intrinsically to protect itself from intrusions. A DL, or a double layer, is where the strongest electric field will be in any plasma will be found. And plasmas isolate themselves from foreign intruders by surrounding themselves with a double layer as a protective sheath. That's just, they have a behavior that's almost as if they had their own intelligence, so to speak. Well, he was followed by Hannes Alfvén, who was 1908 to 1995. Notice we're getting to recent years here. This is a new technology. And this guy was first to predict the large-scale filamentary structure of the universe back in 1963. That's when it first proposed, by the way. He first proposed the mechanism for the acceleration of cosmic rays, now known as the Fermi mechanism. He was awarded the Nobel Prize in Physics in 1970, and on it goes. In February of 1981, 11 years after Swedish electrical engineer Hannes Alfvén won the Nobel Prize in Physics, he published Cosmic Plasma, a book which has been largely ignored by the astrophysics community. And what you're going to see here is stuff that the astronomers, the astrophysicists, have chosen to ignore, to their peril, as it turns out. Our space probes have confirmed his views. So this is giving the point, we've got evidence now combining. Over 99% of the universe is composed of electric plasmas. And they obey, here's the important thing, they obey the same laws as small laboratory plasmas do here on the Earth. We can recreate these shapes and forms in the laboratory. We understand that behavior, and it turns out we're observing that behavior in the galaxies. So you're getting empirical confirmation here. We get to Anthony Peratt. He's an author of The Physics of the Plasma Universe, which I encourage you to get a copy if you're technically oriented. Numerical and experimental contributions to high energy density plasma, tense particle beams, explosively driven pulse power generators. You can already tell this thing's getting classified, isn't it? Lasers, intense power, microwave devices, particles, high energy density phenomena, Z-pinches, and a bunch of other things that I'll show you up here in a minute. He's at the Los Alamos National Laboratory from '81 to the present, serving Applied Theoretical Physics Division, and so forth. And he's also scientific advisor to the United States Department of Energy, where he served as acting director, National Security and Nuclear Proliferation Directorate, and so on. He made large-scale simulations of the Maxwell-Lorentz equations, and he was able to yield the same results in those simulations that are indistinguishable from the astro images from actual galaxies. And here's a group of the pictures. These were done in the laboratory, and we see the same shapes and behavior that we observe through telescopes. So it's interesting confirmation. The effects of gravity are minuscule. The effects of electromagnetism can be 10 to the 39 times more. The entire volume of our galaxy consists of magnetized plasma. 99% of all matter is plasma. Here is a picture of M31. You've seen this in all your astronomy textbooks, a very common picture of Andromeda, as it's called, right? That's invisible light. Let's take a look at this in infrared. And you begin to see the electric structures that underlie that thing. And we look at M82, and if you look at it in other frequencies, you realize it's a plasma structure. If you look at it infrared, as you look at these, you begin to realize that there are aspects to those structures that are not normally visible in light. And you can almost see the axis, and you can see the other behavior. Maxwell equations. There are 4 partial differential equations that relate electric and magnetic fields to the sources, charge density, and current density. And these equations can be combined to show that light is an electromagnetic wave. The interactions of electrostatic and electromagnetic forces are very non-intuitive. One of the problems in this area is we're not talking about 1 or 2 dimensional relationships. We can deal with 1 or 2 dimensional relationships. We can't normally deal with mutually orthogonal relationships. I'll show you what I mean. The forces are orthogonal to the fields. And the resulting plasma takes on a unique aspect as a composite body with a very distinctive character. You see, the magnetic field is in one direction, the velocity is in a different direction, and the force is these are all mutually orthogonal. Each one is 90 degrees from the other. And that their behavior among themselves is very non-intuitive. You've got to experiment these to get a feeling for how plasmas behave, because these are all mutually orthogonal. Are you with me so far? Okay. In fact, the engineers will speak of a right-hand rule. If you have an electric current, around that electric current there'll be a magnetic field. If the current is changing, the field will be changing. If the field is changing, the current will be changing. They're intrinsically hooked, and they're hooked with what they call the right-hand rule. You put your thumb in the direction of the current, your fingers will point in the direction of the field. You with me? They're inextricably linked, okay? You don't have one without the other. And that's the net of those equations, the so-called right-hand rule. Now, it turns out that plasma you don't normally see. It has 3 modes. It can be dark, where there's no light admitted. You don't see it normally. The Earth's ionosphere, except during auroras, is invisible, okay? Electric current, if the current is very, very low, you don't see the plasma. Now, you add a little more current, it goes in what they call the normal glow mode. When you see a neon sign, that is in the glow mode. It's a plasma that's going through that tube. It emits light. Auroras, emission nebula, the sun's corona, and comet trails are all examples of plasma that is in normal glow mode. The brightness, intensity of the current, and density of the plasma and so forth. The color depends on what gas is being ionized here. Okay. Then you get to the bright one, the arc mode. You got dark, normal, and then arc, which is extremely bright and a very wide spectrum of emission. Electric welding. You never look with unprotected eyes at someone doing electric welding because you're seeing an arc and it has frequencies that'll hurt your eyes. The sun's photosphere. You never look directly at the sun. And lightning. Fortunately, it's so brief it won't do that much damage to you. And sparks are examples. It's characterized by twisting filaments both in the ultraviolet and in the radio frequencies. We also encounter a strange thing called the Z-pinch effect. High-intensity current passing through a plasma will take on a corkscrew or spiral shape. This was discovered by Birkeland, so they're called Birkeland currents. They most often occur in pairs, and they tend to compress between them any material, ionized or not, in the plasma. And they call this the Z-pinch effect. I'll show you that in the diagram in a minute. Cosmic matter tends to form an abundance of these filamentary, stringy kind of structures. The initial velocity of a particle is perpendicular to the magnetic field. The path that the particle takes is a circle in the plane perpendicular to the field. However, if the initial velocity of the particle is at an angle different from 90 degrees to the magnetic field, perhaps slightly in the same direction as the field, then the path will be a helix or a spiral. The stronger the field is, the smaller the radius of the circle will be. No matter what the initial direction of the current stream, it will end up following the direction of the magnetic field. And here's a diagram of that. It's called a Birkeland current. Okay? It starts at a helix and it gets tighter and tighter and tighter. And that's the side view there on the left. To the right there is the top view, and what is being squeezed in there is called the Z-pinch. Whatever material in there is being squeezed by the Birkeland current. This just happens naturally within a plasma. These are very non-obvious things. The only way you discover this is by playing with them in a laboratory and discovering them. Both in the laboratory and in the cosmos, a pair of such spiraling currents will be observed. The interlinked pair will at first be magnetically drawn together, but after a certain proximity is achieved, the force of the repulsion is generated that holds them apart. This configuration turns out to be extremely stable. That's why it can span such enormous distances in our galaxy. The resulting tightly worn pair is called a Birkeland current. The attractive repulsive forces acting on this pair of currents creates a twisted, constricting, cylindrical volume inside the spiral where extreme compression of matter can take place. When this occurs in cosmic space, the associated plasma filaments can be observed by the radiation they emit. Now, don't confuse this with the conjectures of gravity people about black holes. Black holes are conjectures. They're conjectures that are driven by a dependence of gravity. Gravity is not a factor. The plasma factors are. The scripture talks about stretching the heavens. Have you noticed that in the word? The fabric of space. Is this more than just a metaphor? Who alone stretches out the heavens in Job 9? Stretching out the heaven like a tent curtain in Psalm 104, who stretches out the heavens like a curtain and spreads them out like a tent to dwell in Isaiah 40. Are these just figures of speech? He has stretched out the heavens, Jeremiah 10, the Lord who stretches out the heavens in Zechariah 12, and on it goes. I could go on and on with these phrases throughout the scripture. They're familiar to you. Too consistent to be just figures of speech. Space, by the way, we discover, is not an empty vacuum. That's the presumption of science fiction writers who haven't done their homework. Space can be torn, Isaiah tells us in 64 chapter. It can be worn out like a garment, Psalm 102 tells us. It can be shaken. Can you shake empty space? Hebrews 12, Haggai 2, Isaiah 13, I'll make those references. Space can be burnt up, according to 2 Peter 3. You want to talk about global warming, Peter will explain it all to you in the 3rd chapter of his 2nd letter. Here's the interesting one. Space can apparently be split apart like a scroll. Really? Revelation 6. It can be rolled up like a mantle or a scroll. Now, wait a minute. For something to be rolled up, it must be, in some sense, thin, and there must be an additional dimension into which it can be bent, right? The grammar requires that. Rolled up. See, there must be some dimension in which it can be thin, space can be bent, then there must be a direction into which it can be bent upward. Thus, there are additional spatial dimensions, and 10 is a current estimate. The 4 we directly experience, and 6 that occur in less than 10 to the minus 35 centimeters, or they're smaller, they can only be inferred indirectly. Now, we also if you run into astronomy, you discover this Heisenberg formula. That's the barcodes of the atom. They're spectral lines of hydrogen on a logarithmic scale in this particular illustration. And it was invented by a Swedish physicist, Rydberg, in 1888. It's used in atomic physics to describe the wavelengths of the spectral lines of chemical elements. Very interesting, except we discover certain stars have their lines shifted to the red, but not always, sometimes to the blue. Ooh, why? The so-called red shift, back in the 20s, Edwin Hubble suggested what was called the Doppler effect as an explanation. He felt that the red shift was caused by these stars moving away from each other, like the Doppler effect. That remains, to this day, a widely accepted explanation, even though it's been punctured, by the way. In 1976, William Tift of the Stewart Observatory in Arizona noticed and documented the aberrant and digitized nature of red shifts. He spent 20 years doing this. In the 1980s, Guthrie and Napier at Edinburgh Observatory spent 10 years challenging the view of Tift and confirmed that Tift was correct, that these shifts are digitized. There's specific steps, which says they can't be a Doppler effect. They have something intrinsic to do with the molecular structure. Robert S. Millikan in 1925 noticed that the wavelengths of spectral lines were shifted from the theoretical position and was among the first to recognize that energy in space was battering the atoms and affecting their movement. These spectral lines are due to electrons moving between the energy levels of the atom, not the Doppler effect. And yet you find these old myths still populating our textbooks in college, let alone high school. Now, the ambient energy in what we think of empty space has come to be called the zero-point energy. And boy, this is a whole area of controversy in its own right. Zero-point energy, we think of empty space, especially if it's super cool and all that sort of stuff, as being an empty vacuum. Anybody here is a radio ham? If you're a radio ham, you try to tune your antenna to the impedance of space, right? You mean space has impedance? Absolutely. Every radio ham knows that. Max Planck in 1911, and then Einstein, Stern, and Nernst also recognized that this pervasive energy was a universal phenomenon intrinsic to space itself. Through the work of Heisenberg and others, it began to be understood that Planck's constant was actually a measurement of the uncertainty in the position of subatomic particles. By 1962, it was realized that this uncertainty of position was caused by the battering from the zero-point energy. The Heisenberg uncertainty effect is widely misunderstood, and it's, of course, exploited by the New Agers who don't understand anyway, but that's neither here nor there. This energy is independent of temperature or mass, by the way. That's a surprising thing. In 1987, Hal Puthoff showed that the electrons stayed in their orbits and did not go either spinning out or spinning in due to the expended energy, precisely because of the energy they received from the zero-point energy. You ever wondered why these electrons keep spinning? Why don't they slow down? Because they're drawing on the zero-point energy. About 25 different methods, 475 measurements on 11 different related quantities confirmed that E is equal to, that the energy, which is constant, is Planck's constant times the speed of light. If the speed of light is slowing down, then the Planck's constant is increasing. And that's disturbing because we're discovering it is, and that's pulling the rug out from much of physics today. Properties of space. The zero-point energy is about 10 to the 95 ergs per cubic centimeter, and that's an unbelievable amount of energy per every cubic centimeter in space, empty space. It has permittivity, the absolute electric constant. It has permittivity, it has permeability, it has intrinsic impedance. Anybody that designs antennas deals with these things. And the velocity of light is essentially at the speed of gravity today. Well, it's interesting that Hebrews 11:3 says, though through faith we understand that the worlds were framed by the word of God, so that things which are seen were not made of things which do appear. How descriptive. One of my favorite Psalms is Psalm 19. The heavens declare the glory of God, and the firmament showeth his handiwork. Day unto day uttereth speech, and night unto night showeth knowledge. There is no speech nor language where their voice is not heard. Their line has gone out throughout all the earth, and their words to the end of the world. Now, my professional technical background happens to be in the information sciences. I have masters and doctorates in a number of fields, but that's my primary specialty. I'm fascinated because this psalm has information science. Oh, the other thing, as you study any field of science today, you'll discover that the frontier of that science lies in the area of information science. In the field of physics, you get into to quantum physics. It's an information science issue. If you go into microbiology, the whole thing is the coding of the DNA and all of that. That's an information science, switching theory issue and so forth. The information science is at the frontier of every one of these. The heavens declare the glory of God. The firmament showeth, these are information terms. Day unto day uttereth speech, and night unto night showeth knowledge. There is no speech nor language where their voice is not heard, and so forth. Their line goes going throughout all the earth. Their words to it's interesting, this whole thing is information sciences. And it's interesting to me that one of the titles of our coming king is the Greek term for word, logos. How interesting. Their line has gone throughout the earth, their words to the end of the world. In them hath he set a tabernacle for the sun, which is as a bridegroom coming out of his chamber, and rejoiceth as a strong man to run a race. His going forth is from the end of heaven, and a circuit to the ends of it. And there's nothing hid from the heat thereof. How interesting. You know, the cynics will say, see there, everybody knows the sun doesn't rise in the east and set in the west. No one said it did. That's not what it's talking about. And if you look at all of this, and look at a map of our galaxy, you know, the sun it does travel literally from one end of heaven to the other, in an astronomical sense. And it's interesting also, it happens to be in the location in the galaxy that makes it possible to see the rest of the galaxy. And that's one of Richards and Gonzalez's book, The Privileged Planets, is a must-read, because you'll discover the universe was designed to be discovered. Not just for life, but discovered. The source for the entire solar system is, of course, the sun, as that psalm suggests, and nothing hid from the heat thereof. When you see an eclipse, you see the corona, and anyone that has any experience with electromagnetism will tell right away that is a huge electromagnetic phenomenon. Okay? It was designed to be discovered. If you take the size of the sun, the size of the moon, the distance from the moon from the earth, and the distance of the sun, you discover that these dimensions have to be an exact number in order to see the corona. It turns out that these two distances and these ranges have to be in a precise relationship. If it isn't, the moon will be too big to blot out the whole thing, or if it's too small, you'll be blinded by the rest of it. It's exactly the size and relationship when the moon goes in front of that sun on a total eclipse, you can see the corona. And because you can see the corona, you discover spectroscopy. And out of spectroscopy, the whole universe starts to open up. And you begin to realize this was not only designed, it was not only designed for life on the planet Earth, it was designed to be discovered. And what a breathtaking thing that is to encounter. If you take a temperature profile of the sun, it's really quite surprising. Because the photosphere, the chromosphere, the corona is at a higher temperature than the rest of it. That's a surprise. Well, I thought the sun was just some kind of nuclear explosion. That's a guess. That's way out of whack. The sun, you're going to discover, is a very sophisticated light bulb. It's electromagnetic phenomenon. This is the temperature profile. If you take a voltage profile, it's somewhat the inverse of that. And as Bob Schober points out to me, this is simply identical to a solid-state PNP transistor. Boy, is there a clue there. Is that the way the sun is getting its energy as it passes through the fields of the universe? I'm expecting Bob to put his hat on and figure out a way, can we get a way to tap that energy for the SwanSat satellite system? That would be an exciting possibility. But there are electric currents in the sun, and here's a map of them. If you have a main current flowing in at both top and bottom, and they flow out at the perimeter, it creates secondary currents in each side, and those are now beginning to be understood. And if the main magnetic field starts to weaken intensity, a secondary surface current will reverse direction, and the magnetic polarity of the loops will also reverse. It does not depend upon the direction of the primary current. It's a question of strengthening or weakening. And these reversals appear to occur about every 11 years. And they have profound effects on what goes on the Earth, by the way. And so, if you have what we call a solar prominence, from a strong looping current will produce secondary magnetic field. It will surround and try to expand the loop. If the current becomes too strong, the double layer that contains it will be punctured, and if the voltage gradient becomes strong enough, the discharge path will break. The energy stored in the primary magnetic field will be explosively released into space, and you have what's called a prominence. That's piercing the double layer that produces what we call here a solar flare. How many have heard or seen solar flares? There's the electric diagram that explains them. Okay? Now here's a picture of the sun. There's the plasma magnetic field pictures of them. You can, by the very curvature, you can sense their magnetic properties here. Now, here is a very prominent solar flare. Let me show you the size of that. Let me put the Earth synthetically. It wouldn't get this close, but if the Earth was here, that's where the Earth would be. That's a big flare. That's the relative size of the Earth on that flare. Now, I'd like to show you, I'm hoping this will work now. This is a film strip that will show you these flares, and you see them in motion. It doesn't take any imagination to realize what you're watching there is magnetic phenomenon, following the lines of force of these magnetic fields. These are incredibly descriptive, and that's not gravity at work, that's electromagnetism at work. Those are Birkeland currents that you're watching, okay? Well, anyway, we'll move on here. Look at a leaf. You discover that it's been designed to take those frequencies from the sun and produce a lot of different things. You have a thing called photosynthesis, which is being built with light. These are sugar factories with millions of new glucose molecules per second. Most plants produce more glucose than they use and store it as starch and other carbohydrates and root stems and leaves. Each year, photosynthesis organisms produce about 170 billion metric tons of extra carbohydrates, about 30 metric tons for every person on the earth. So we have an amazing dependency, not only in the design of the universe and the design of the sun, but how the plants produce the oxygen and the sugar to feed the animals, and how the animals produce the CO2, which causes the whole thing to work. And we find the interconnection here is so complex, I couldn't take the better part of an hour just to explain the different steps in the photosynthetic process. But the elegance of design, the more you study it, staggers you to realize the degrees to which God went to provide the environment that we enjoy every day. Genesis chapter 1, and God said, "Let there be a firmament in the midst of the waters, and let it divide the waters from the waters. And God made the firmament which divided the waters which were under the firmament from the waters which were above the firmament, and it was so." There are two words that are translated here by the 1611 translators that need a little more reach. Rakia actually means an extended surface, expanse. It's labeled firmament in our English translation. It's an expanse, meaning it is a flat as a base or support. The Hebrew word signifies like a sheet spread or a curtain drawn out, is the thought. The other word there, that's mayim, which is translated waters, recognize that it's a term as close as they could get to suggesting fluids. Transitory things, fluids. And I'm going to suggest plasmas. That term was invented when we discovered what plasmas were. It also can mean danger or violence. It implies motion, if you will. So let me take a liberty here and use modern terms and translate those things. And God said, let there be an expanse in the midst of the plasmas, and let it divide the plasmas from the plasmas. And God made the expanse and divided the plasmas which were under the expanse from the plasmas which were above the expanse, and it was so. So I suggest that as a possibility. God challenges Job. He says, can thou bind the sweet influences of the Pleiades or loose the bands of Orion? These are constellations that are tied together, not by gravity, by electromagnetism. The seven sisters, the Pleiades, are a group of stars, but they're physically, they look like they're together. They're actually quite distant between them. What's binding them together is the equations of James Clerk Maxwell, not the equations of Sir Isaac Newton. The boundaries of reality. We've gone a quick glimpse here, talk about size to the right. We've talked a little bit about the macrocosm, that it's finite, and that's led to all kinds of conjectures that need to be repaired in both astronomy and astrophysics. On the small side, the microcosm, we've talked about the indivisible units, the quantum physics, and subatomic particles. There is a concept that ties this all together. Because if we take a look at the metacosm, we know that we're in a digital simulation. We talked about that. Our universe is but a shadow of a larger reality, praise God. But what ties us together in the microcosm, we've been talking about the zero-point energy, right? And what ties that together to the macrocosm are the plasmas. And so we really close the loop, if you will, if you follow me here. I encourage you to get a book by Donald E. Scott. It's not only, it's an excellent tutoring device, because he's an outstanding communicator, and he makes this whole subject very direct and illuminating without talking down to you. The Electric Sky, a challenge to the myths of modern. Much of what I've drawn here is drawn from his book. It's readily available. A more technical term, maybe more greater historic interest, is Pratt's Physics of the Plasma Universe. But if you Google any of these guys on the internet, you will get a plethora of resources and references that will take you through this. Now, we put what you've experienced here this evening is the boundaries of what we call the Boundaries of Reality series. We did a thing called Beyond Time and Space many years ago, talking about the impact of Einstein's theory of relativity and the nature of time and the nature of space and hyperspaces. We've just republished that, freshened it up, and put it out as a DVD for those that are interested. Another one that we started 14 years ago, Beyond Coincidence, the evidence of deliberate design, the anthropic principle as it's called, the hidden messages that are in plain sight, and how sure can we really be that the Bible is the Bible? And we deal with that head on in a thing called Beyond Coincidence. And then the third one in the trilogy was Beyond Perception, which is basically the nature of matter, the subatomic world, the holographic universe, and the dimensions beyond our own. And we call that Beyond Perception. This was our famous trilogy that we've just republished and freshened up and brought up to date, but we've added a fourth to the trilogy. So I guess I have to call it a quartet now. And the fourth one that we've reviewed, perhaps superficially tonight, I call it Beyond Newton, challenging the myths of astronomy, the Burnham celestial model, the plasma universe, and so forth. And we've also packaged these all four into a package for those that want to do that for what it's worth. So I encourage you to explore that. So I think I'm out of gas. I do want to highlight something that you need to know. How many of you are saved? Can I see your hands? Praise God, that's step one. That's more important than anything else. That job was done 100% at Golgotha by our coming King. But many people are not aware that there's a second step. Do you know that the disciples that were called, they were saved, but they were called. How many of you don't have to show, well, how many feel that you're called to be a disciple? Okay, see, there's not quite as many hands. Okay, I understand that. That's candor. See, the first thing is to discover your salvation. It's available in Jesus Christ by just trusting Him. Praise God, He did it all. You can't add to what He did. That would be blasphemous. But there's another step that you want to be sensitive to. Did God save you? Why? Why? There are many stories in this room Some of them very dramatic, some maybe quite straightforward. But every one of us in this room that can raise their hand about being saved are the result of a miracle. I believe that miracle is the result of someone's prayer. The question is, why were you saved? There's a collective reason to glorify God, of course. I'm going to suggest the possibility of a specific reason. God saved you for a specific calling. And let me tell you candidly, I've been married for 53 years. I've been a Christian for, 65, I guess. I've had a life of incredible adventures, and I won't bore you with that panorama, except to make this point. In a life of incredible adventures, the most exciting one is right now. To discover your calling. The most exciting thing you'll do in your life is to discover what God called you to do and then to trust Him in pursuing that calling. Now, I wouldn't presume to even guess what your calling might be, but I'll make you an offer you can't refuse. If you choose to join us, our institute will covenant to help you find, to achieve that calling, however you define it. When you get to the point in your walk that you believe you know what God has called you to do, we will help you prepare for that calling. And you can do it on the internet. You don't have to be face-to-face, although it helps. So I want you to be aware of the fact there is a think tank that you can be part of. It's called the Koine Institute. We've spent the last 6-7 years putting it together. We now have members in 70 countries. And these members collectively covenant with one another to help each other achieve whatever they believe their calling is. You define that. We don't. We wouldn't presume to do that. But that's what we're all about. We have an intelligence network that's fed by all the intelligence services on the planet Earth. Our think tank has 3 different avenues of study. What we call the Berean Avenue is the Bible, verse by verse, cover to cover, and that takes priority over everything else, of course. We call that the Berean Avenue of study. We have a second avenue of study that's very different. For lack of another name, we call it the Issachar Avenue, after the sons of Issachar who understood the times and knew what their country had to do. We've discovered that the tools and resources of that second avenue study is antithetical to the first. In the Berean Avenue, you know that the Bible's true. The question is to understand it. In the Issachar Avenue, you're dealing with intelligence reports, news clips. You know the information isn't true. It's biased. It's been tainted, what have you. The challenge is to discover what is true. Different set of tools, different set of resources. And it's the Issachar database that is the nexus for all the major intelligence services that feed it. The third avenue is the practical doing. We call it the Koinos track. Berean, Issachar, and Koinos. The Koinos track is motivated by the third commandment. Thou shalt not take the name of the Lord thy God in vain, which we argue has nothing to do with vocabulary. It's not about swearing. It's about ambassadorship. If you're going to take the name of the King, you better be prepared to represent him faithfully and competently. And our commitment to you is if you choose to join us, and that, by the way, don't misunderstand, this is not in lieu of church, local church. Local church has a role that's absolutely pivotal. Scripture makes that very clear. But we are there to be a supplement. That's geographic, it's transnational, it's worldwide. It's a lifetime commitment, a commitment to your growth. And you can be part of that. So my challenge to you is to get a little blue handbook. They're free, that explains how this peculiar entity. I spent, as you know, a good bit of time in the strategic arena, and I spent some time in the RAND Corporation environment. And I realized that there's a think tank for Christians. And that's what emerged out of this search last 7 years ago. And so I encourage you to pray it through and see if it's something that would supplement what you're already doing. It won't replace something you're doing, don't misunderstand me. But it is a resource that you might find important. In fact, I'm going to suggest to you something else. I usually close a talk with a slide. I spared you that tonight. I didn't know I could steal a little extra time. I usually put on the slide a statement that if you accept the statement, you flunk. I believe it sincerely, but I want you to challenge this preposterous belief I have. I believe you and I are being plunged into a period of time about which the Bible says more than it does about any other period of time in human history, including the time that Jesus walked the shores of Galilee. Now that's a preposterous statement. That we're moving into a period of time about which the Bible says more than it does the gospel period? Absolutely. The gospel period took care of his first advent. For every prophecy in his first advent, there's at least 7 or 8 of a second advent. And we're watching on a horizon these things come to pass. Psalm 83 is coming, I believe, ahead of Ezekiel 38. These things are happening on a horizon. You will not the more you know about what the Bible says, and the more you know what's going on in the world, the more you'll see the convergence. So to challenge this ridiculous, preposterous statement I made, you've got to do 2 things. The first thing you've got to do is find out what the Bible says. Not what Chuck Missler says, or anybody else. You can't delegate that to anybody. You need to find out what the Bible says. Your eternity depends on it. The second thing you've got to do is not as easy. You've got to find out what's going on. And you won't on the 10 o'clock news. The great lesson of the 2008 elections was the demonstration, beyond doubt, of how the media conspired to hide the truth from the American people. Not just bias, not just a liberal bias and all of that. That's been always around. No. Something far more serious. Because the purpose of the media is to inform the electorate in a democracy. And we've elected someone into office that we don't know one grade they got in any of his schooling since he was born. We know absolutely nothing about his history. And we certainly weren't aware of the fact he's a practicing Muslim. And we put him in the White House. That's not his fault, it's our fault. And the conspirators that did it is the mainline media. The fact that they were organized that well to pull that off is a study you need to come to grips with. You need to understand that we live in the age of deceit. The corruption in the judiciary, the corruption in the legislature, the corruption in the executive branch, the corruption in the entertainment industry, the corruption in our schools is staggering. Okay. That's what we're facing. We talked about trillions here. I mentioned that earlier. We need to understand that the economy of the United States is no longer a producing economy, it's a consuming economy. And the only reason we can go about our lives is because of our ability to borrow from foreigners. And that's ending. It may end abruptly here before this year is out. So what does that mean for us? I'll tell you one thing it means, and pay attention to this one. You and I are going to face, on the near horizon, the biggest harvest for the kingdom of our lifetimes. People who today are apathetic, complacent, are going to soon be desperately looking for answers. And you need to be prepared to provide those answers. It doesn't happen automatically. It happens by serious commitment on your part to be an ambassador for our coming king. I spent most of my college years passing on review on Warden Field of the Naval Academy. I took a commission in the Air Force, left as branch chief of the Department of Guided Missiles. I spent my 30 years in the corporate boardrooms of America in 12 public companies. I was chairman and CEO of 6 different public companies. 4 of those were defense contractors, publicly traded. I'm not an America basher. But I have to tell you candidly, I now look back on much of what I used to call patriotism as an obsolete form of idol worship. My allegiance is to a coming king. And that allegiance prioritizes everything in my life every day. And I challenge you to consider the same thing. It's time to get serious about your Redeemer in your personal life, in your commitment to growth personally. God is not finished with any of us in this room, me included. You need to raise the bar on your personal walk. You need to discover what it is He's calling you to do, and prayerfully pursue that. Every day, God finds a new way to ask you a question: do you trust me? And this is one of them. And I've really overstayed my thing. I think I'm so overwhelmed by the opportunity to be here.